Okay, we're looking at mixed exercise 6 from the first year core textbooks. So we're on circles. I'm on question 20, which looks like an interesting one. We might split this one up over 2 videos because I think it's going to be quite long. Okay, so we've got a circle. We're told its centre and we're told its radius, so we can get the full equation of the circle if we need it. We've got line 1, which is this one here, and we're given the equation of that, and we need to find. Okay, so not such a bad start. So we won't look at the rest of it to start with. We'll just take it in bite-sized chunks. So A is finding basically where the circle, or where this line intersects the circle. So I'm given the centre. So the equation of the circle will be x minus 6 all squared plus y minus 9 all squared equals root 50 all squared. Okay, so that's just putting that top line into the equation of the circle. And I need to find where line 1, which is x plus y minus 21 equals 0, cuts the circle. So I don't think it really matters whether I substitute in for x or y. So I'm going to make y the subject. So y is 21 minus x. It would be perfectly fine if I made x the subject. In fact, it would be x equals 21 minus y. So it wouldn't be any easier, any harder. So I'm going to substitute that in for y, and then I'll have a quadratic in x that I'll be able to solve. So, okay, well, where that came from. Right, let's write that out, and then we'll worry about multiplying out brackets and things. So 21 minus x minus 9 all squared is 50. So that's these brackets here can just become 12 minus x. So let's do that there, save writing everything out again. Okay, so that's the 21 minus x and then minus the 9. So we need to square all those brackets out. So x squared minus 12x plus 36, the first set of brackets, and then 144 minus 24x plus x squared for the second set of brackets. So then I've got a quadratic in x. So let's just get that solved. So I've got x squared plus x squared. I've got minus 12x minus 24x. And I've got 36 plus 144 minus 50. So that's going to be 130. So we can cancel that through by 2. Or you can just put it into a calculator if you want to. And I think that's going to factorise. So 13 and 5, yeah, 65 can't have that many factors. So I've got x is 13 and x is 5. We can have a quick look on the diagram. Yeah, x should be positive at P and Q. So that's going to be the x is 5. That's going to be the x is 13. So that's looking okay. And then I'm going to go back to this, use this equation to find y. So I've got x is 13. So y will be 21 minus 13. And I've got x is 5, so y will be 21 minus 5. And P is this one, and Q is that one, purely because obviously P is to the left, so P has the lower x coordinate. Right, okay, so not too bad for 5 marks. Quite standard question. So I'm just going to have to think a little bit more from here on. So find the equations of line 2 and line 3, the tangents of P and Q respectively. Okay, so actually having said that, I don't think this is too bad. So, let's just draw it roughly how it looks on the diagram. So if we can pretend that looks a bit more like a tangent. Okay, so we want the equation of those 2 tangents. And what do we know about them? We don't know what they tell us about line 1 and line 2. So all they've told us is they're the tangents at those points. Right, so what have I got? That one was 13, 8, and that one was 5, 16. Okay, so I think what I'm going to do, so I could think about the gradients. So I know the centre of the circle. Yeah, I think that's going to be my best bet. So I know the centre of the circle. They told me that. That's 6, 9. So I also know that the radius and the tangent are at a right angle to each other. They're perpendicular. So what I can do, I can get the, so I'll do them one at a time. So I can get the gradient of the radius. So that's going to be change in y, so 16 minus 9 over change in x, so 5 minus 6. So that's 7 over minus 1. Sorry, let's move back a little bit. So that's 7 over minus 1, so minus 7. So if that radius has a gradient of minus 7, then this tangent that I'm trying to find is perpendicular, so has a gradient of a 7th. And that looks reasonable to me. And that looks like it might be a gradient of a 7th. I don't think I've done anything daft with my signs. So let's move down here a little bit and do that calculation. So this tangent here goes through 5, 16, and has a gradient of a 7th. So I'm going to use y minus y1 is m times x minus x1. So y minus 16 is m times x minus 5. I'm going to multiply it by the 7. I'm going to do 7 times 16 on my calculator. Okay, and I don't think we asked for it in any particular form. I'm looking at B, aren't I? No, so just find the equation. So I'm going to just take everything over equal to 0. So that'll be 7y minus x, and then adding 5 on, so minus 107 equals 0. And I'm going to check that answer. Flagging a little bit, right? Let's see. Yeah, that would be the equivalent of what we've got. Okay, so that's one of my tangents, and then we need, let's use a different colour. We then need this one here. So exactly the same thing. So if I do the radius, if I do the gradient of radius, that's going to be perpendicular. So the gradient of that is going to be change in y, so 9 minus 8, over change in x, so 6 minus 13. So that gradient is 1 over minus 7, so minus a 7th. So let's just do the working down here. Right, so I've got my coordinate it goes through, and the gradient of the tangent is perpendicular to this one, so it's going to be a gradient of positive 7. Okay, so again, I'm going to use y minus y1 is m times x minus x1. So y minus 8 is 7, x minus 13. So y minus 8 is 7x. I'm going to say 91. I'm going to check that in a sec though. And again, I'll just bring everything over to the left-hand side. So y minus 7x. I'm adding 91 on, so that is going to be plus 83, maybe. Let's check that. Plus 7x minus 83. Yeah, so they just kept it all in the form y equals mx plus c. Okay, so far so good. Okay, we'll carry on to part C. This is quite a long question, this one. Okay, so find the equation of line 4. Crikey, where's line 4? Right, so line 4 is this one going through the centre of the circle. Perpendicular bisector of the chord PQ. Okay, this question really is just a test of endurance, I think. It's not, none of the individual bits so far have been that bad. It's just keeping going with it. Okay, so there's P and there's Q. Line 1 is the perpendicular bisector, and if it is bisecting a chord, it looks like it goes through the centre, but it doesn't actually specifically say it does, I don't think. Did they mention A anywhere? Oh, there we go. Yeah, well, okay, well, let's worry about part E when we get onto part E. Okay, but it will be, yeah, so if we're bisecting a chord, we will be going through the centre of the circle. And we know that the centre of the circle is 6, x9. And PQ, I don't think, have I found the gradient PQ yet? I don't think I have, but that's fine. But I have got P and Q. So P was 5, 16, and Q was 13, 8. Okay, so if I can get, and I'm looking for the perpendicular bisector. Okay, so if we get the gradient of PQ, so change in Y, so 16 minus 8 over 5 minus 13. So 8 over minus 8, I think I get that to be. Just about get that on there. So PQ has a gradient of -1. So that has a gradient of -1, which would mean line 4 has a gradient of 1. And line 4, well, so I could find, if I hadn't picked up that it goes to the centre, I could just find the midpoint of PQ, but the perpendicular bisector of the chord PQ will go through the centre of the circle. So it will go through 6, 9. So we'll save a little bit of effort and just use that. So y minus y1 is m times x minus x1. So y minus 9, 1 times x minus 3. So y minus 9 is x minus 3. So let's just give that in the form y equals mx plus c. That seems to be what they've done for most of theirs. Okay, so y equals x plus 6. No, what have I done daft? No, it doesn't go through the centre. Yeah, it does go through the centre. So centre is 6, 9. Oh, for goodness sake. Okay. Just making up numbers, right. Okay, so that was never a 3. That's why our answer doesn't work. That was a 6. That's more like it. Right. Okay, bye.